Welcome to this talk about Unity's audio system. It's an in-depth talk, and we do have a lot of new features in Unity 5. So who am I? My name is Jan Marguc, and I work as a full-time audio programmer in the Copenhagen office of Unity. Before that, I worked at IO Interactive on the latest Hitman Absolution game, and also worked at TC Electronic, who do mostly audio plugins and guitar effects and stuff. And what got me into programming was the demo scene, and that I like to play as much music as I have time for. So Unity 5. We have a lot of new features, and that's why we'll devote a lot of time to speaking about the upgrade path from Unity 4 to Unity 5. The biggest feature of Unity 5 is the audio mixer. And if there's time at the end, I'll also show some applications of the native audio plugin system, which you can use to extend the features that are not in Unity 5. So one of the biggest changes in Unity 5 is that we have refactored the AUDIOCLIP significantly, meaning that the audio data is no longer stored in the AUDIOCLIP asset itself, but is actually stored in a separate file. So that's the audio clip now just references the audio data, and you have a lot of control over how you want to load that data. And that means that we are saving a lot of space this way, but this is not limiting functionality. You can still query the audio clip about the length, the channel count, sample rate, all that stuff you would like to know up front before you start loading your audio data. For instance, if you're doing a dialogue system or a music system where you need to schedule clips to play in succession. And this is what the API looks like for it. You can either load the data on demand, that is on the first play call or on the first play one-shot. Or you can do the loading completely manually with load audio data and unload audio data. And there's also, if I zoom in here, you can see there's also an option for loading the audio data in the background. And you can still, the old behavior from Unity 5 is still that the audio data will be preloaded when the audio clip is loaded. So we're not changing that. But you have the option to defer that now. And you should, of course, consider if it's a very long audio file that you're loading, then it might take some time to load that in the background. But the nice thing about it is it works completely generically, so it also is now able to decompress audio data in the background. It's not just streaming that's working in the background. And you can query the load state using the load state property on the audio clip, and audio loading might fail, so this will tell you. Or it might be just take a long time to load, and then the audio state loading will be the state that it's in. And we should also say it's much more consistent now between the runtime players and the editor. Previously, streaming wasn't really streaming in the editor, so that's now what you see in terms of memory usage is actually much closer to the real thing. Of course, always when you profile on the actual platform, because there are some differences still between the player and editor. We also got much better control over compression now, because you have this, in this red box you can see there are different platforms you can select, and you can go in and override different settings per platform. And we have some new codecs for the different platforms. So we have PCM. This is what we previously called native. It's uncompressed data. We have Vorbis compression, which generally performs better than MP3 in terms of compression quality. And we have ADPCM. And ADPCM I want to talk a little bit about, because this is what you should consider for many natural types of sounds that contain a fair amount of noise already. And most natural sounds do that, such as footsteps, gunshots, and impact sounds. And the good thing about it is it's very, it has a predictable 3.5 compression ratio, and it is pretty light on the CPU. So it's getting very close to PCM. But if you use it on very pure sounds, you will hear that it's adding some frequency-dependent noise. So because it's trying to approximate the signal, and the higher the frequencies get, so to speak, in the signal, the more noise there'll be. While if it's a very slow, low frequency signal, it'll be able to approximate that pretty accurately. We also allow changing the sample rate for ADPCM and PCM. You can either have Unity do that for you, or you can manually override it with these settings. And yeah, we have multi-select editing, which has been, I guess all of you know what pain this has been previously. But it first made sense to change with all these refactorings we've done. We've also changed some things on the audio source side. We no longer have the 3D property on the audio clip. We took that and actually moved that into the audio source. And the way we moved it, it became this spatial blend slider. So you can actually now define the sound to be a hybrid between 2D and 3D. And what will happen when you upgrade when you load your old Unity 4 project is it will see if there's an association between your scene where you have audio sources that reference audio clips that previously had this checkbox, the 3D property checked. Then it will automatically adapt the spatial blend. Otherwise, the new default value, if you just put in a new audio source, the spatial blend will be 2D. And so you might know the pan parameter. We now renamed it to stereo pan because it's a little bit more exact about what it's doing. So that's for your 2D games. You can do the typical left-right panning. And we also added the reverb zone mix parameter. So if you have reverb zones in your game, now you actually get another curve, so you can specify the transition between your near field sound and your distant sound. So you can. This is what I've tried to draw down here. So you can, if the sound is very close, you want to hear mostly the direct sound without any reverb, and then if it moves away, the distance-dependent attenuation curve is attenuating it, but at the same time, we now have the possibility to push up the reverb zone mix, and that way the sound gets more washed out. Like you can hear it's far away. So that's a very useful effect, I think. We also worked on the pause behavior, so it applies not only to the clips that you start using play, but also applies to the one-shots. And there's also now an on-pause on the audio source. And what you can see up here is there is an output group, and this actually allows you to route the output of this audio source into a mixer. And the mixer is this other big feature that I'll speak about later. But before that, let's look at some really useful tool that we added. Like you might have used the profiler window for profiling a lot of other stuff. We've actually added a lot of audio stuff in it now, which is strictly, it's not profiling, it's more like an audio debugger. And it's really useful when you want to find out if you're starting to hit the CPU budget in your game and you want to figure out which sounds maybe are not needed because they're not very loud, but they are still consuming CPU. You're just not hearing them and not really aware that they are causing a problem. So here is the profile window, and you can see I click on the audio pane, and now I got different options down here. I can say, do I want to see just general stats? Do I want to see the channels that are playing? That's the sounds that are playing, or the groups, and the groups that also relates to the mixer. We'll get into that later. So let's just run Angry Birds here and do some playing. So now I can frame by frame, I can see what was playing in this scene. I can see all kinds of useful information about the distance to the player, the volume, how loud it actually was playing, and I can also click on it, and you'll see it highlights it in the project view and in the hierarchy. So if I'm onboarding a project and I don't really know how the sound setup's working, this would be the first place I'd go and figure out what mess my colleagues have created. No, I didn't mean that. Okay. Next topic, audio mixer. This is one of the big features of Unity 5, and it's a fully integrated signal-oriented mixer that you might see that there are some people at Unity who like logic a lot. That's maybe why it looks a little bit like this. But otherwise, it looks like a typical mixer that you know from different DAWs. So you have your VU meter, you have your insert channels, and you have your solo, mute, and bypass effects buttons. You have send, and you have receive ports that you can send to. And as you can see over here, you also have docking. So I can from a send, I can send into a docking effect. I can send multiple sounds into a docking effect, and that will dock the audio flowing through this channel. So this is pretty useful if you have weapon sounds and you're kind of hitting the dynamic limit already, but you still want to create the illusion of something that is really loud without actually just playing it louder. Then you just dock the other stuff when some loud event occurs. And this docking is also completely signal-oriented, so it's working like a typical compressor where you can select your attack time, release time, and all the parameters should be well known. What's different though is that this kind of mixer is hierarchical. So in DAWs, it's typically very linear, the way that you're mixing, but you can see in this group that it's possible to arrange the different groups in a hierarchy here. So all the player sounds could be down here. So if I make a change to the player group on the volume, that will actually affect all the sounds that are underneath this group. And what you're seeing over here is the inspector. So the inspector always will show you the selected channel. And what we see here is of course the audio source has the output which specifies which of the groups the audio should be routed to. What's also different compared to the rest of Unity is that the mixers are actually assets, and that allows for persistent editing, which means that you can actually edit your mixes in real time while playing the game, because I mean, how are you else going to do it? I mean, you need everything to be playing, and then you make your changes based on what you hear. So that allows, of course, for a very fast iteration time. And finally, or not finally, but also we have snapshots. And the snapshots are probably also well known if you've worked with live mixers. One band comes in, you make the sound check with them, set all the levels, you press save. Next band comes in, you change everything, save again, and you have all these different presets for different situations. And the situations in a game context are, of course, the different. I typically tend to think of them as moods, like there's maybe an idle mode where nothing is happening, the player's going around. You have a lot of ambient sounds, all the small details. Then maybe you get into a suspense mode where something is getting fishy here, and like you take away some sounds to create some space and create some like what's going on, and then you have the third mode, which is like fight, and you definitely don't want to hear the birds chirping or anything. You want full weapon sounds and explosions and stuff. So very different scenarios that you can all set up using snapshots down in this view. And finally, if snapshots are not solving your problem, it's still possible to expose parameters. And that is like any parameter that can be automated by a snapshot. That's basically any parameter that has a slider or a fader or anything. You can actually just control that using the setFloat, getFloat API. So if I call setFloat on an exposed parameter, which I can call anything that I want. So I can actually give it a meaning that is meaningful to the game. If I call this API, then the parameter is completely under my control. And it will stay so until I call clear float, and then the control is handed back again to the snapshot system. I can also query the current value using getFloat. So if I have called setFloat already, that'll just return the value that I set. But if I'm in the mode where snapshots are automated, then getFloat will return me the current value. So I could actually use the snapshot system of the mixer to drive other things, like visual effects, for instance. I could couple that. So just talking about listing all the features of the mixer, we have it's a very graphical tool, and we want our audio tools to be much more graphical in the future. And it's got all the typical things you would expect: sends, receives, inserts, sidechaining, the docking. We have the hierarchies. And we have support for custom UIs, like you see in the docking effect over here. All effects can have wet-dry mixtures, which is pretty useful if, say, you have an effect that you only want in one snapshot, but you want it to be mute in other snapshots. Then this wet-dry mixture actually allows you to mix into that effect and then go out of it again in a different snapshot, and that effect then stops consuming CPU in those other snapshots. Generally, we have done a lot to make sure that we're not running anything that is not active. So also the whole mixer can be automatically suspended if no audio channels are playing into it and the mixer has been silent for a while. So let's look at some mixer demos. I load a different project for this. Actually, yeah, let's just look at one, because it's this one has most of the features that I want to show. And the interesting thing about this is that it's we have 8 tracks here, which are loops, but they are very long loops. But the idea is it's just pretty repetitive stuff. So now we just put all these audio sources in the scene, and we set it up to be routed to the corresponding groups in our mixer. And the mixer asset is this one. So here we see it. And you can see I set up different snapshots. And the main thing I'm working with in this, there are no effects. It's all just levels that I'm working with. So now let's play it. Oh, yes, okay, I have the scene. So I have this funny thing called the drama slider, so I can increase the drama by dragging the slider. And what it does is it'll simply just select the snapshot based on the slider position. So let's increase the drama. So something is wrong, we don't know what it is. Now somebody discovered us. And another thing that is in this setup is that we actually have 2 mixers, 2 different mixer assets. So this was the music mixer, and here I have the main mixer. And this is pretty useful if you work in a company where there are multiple sound designers. Maybe somebody is just working on the music, so only working with the music mixer, and then there's the lead, the audio designer who's integrating everything. So you can just set it up so that music just plays, all the output from this music mixer is played into this music group, and that means that I can go in and I can change the volume of the music just by by doing this. By the way, we are in play mode now, so I'm doing changes in play mode like this now. But what I use it for in this demo is actually that I implemented a pause menu, and when I go into pause, you can see we have a snapshot here called pause, and that snapshot has a low pass filter and increases the amount that we send to the reverb. So when I go into pause mode, it makes it much more muffled. So you see how everything operates nicely, and my neighbor was also very happy when I made this track at 12 midnight and completely didn't realize that other people were sleeping. But yeah. Okay, since we have some time, just I can also show you the docking for some techno music or techno-ish music. So it's the same idea again. We have a mixer. We have some 8 tracks that are just playing all the time. But in this mixer, we have many more effects. We have parametric EQs. We have the docking, and we have a low pass filter, which is placed on this bass line. And that's a low pass with resonance followed by distortion. So we can actually change the sound quite radically with this. So let's hear that, and let's just see how it's iterating through the snapshots. And again, this whole track is just built up by different snapshots, and all the musical transitions are happening through interpolating the parameters. So here you see the docking in action. Actually, it's the bass drum that is sending. The bass drum is sending to the docking that is on the master. So whenever the bass drum is playing, it goes into this region where it stops amplifying linearly and starts docking actually to make room for the bass drum. And when we go into this this section where we have this breakdown. You can hear that the sound on the bass is changing a lot. So just with these built-in effects, you can actually do a lot of changes to the sound that are musically meaningful. Okay. Finally, the native audio plugins framework. If you need even more effects, and of course you do, you are sound designers, you always want more, then you can go to your coder in your company and ask them to add some more effects. But our main ambition with this plugin SDK is, of course, that there are people here in this audience maybe that want to do some cool stuff and put it up on the asset store so everybody can benefit from nice new effects. And we are kind of combining the best of two worlds. Like if for audio you really need all the performance that you can, it's a lot of calculations, so you definitely want to do that code in a native language like C++. Unity is great for prototyping audio effects. If you play with an audio filter callback, you can do a lot of stuff. It can give you a very good idea of how to get started, what parameters your effects should have. But then when you actually want to use it in production, you want to do that in C++. What you don't want to do is GUI development. And luckily, we have C# libraries in Unity for this. So you can do your custom GUIs in C# still. So I really think that's combining the best of both worlds. Oh yeah, and I should mention, all the links that you see at the bottom, they'll be on the last slide also, and this presentation and the demos I've played, and the native audio plugin demos, it's all available for you to download afterwards. So I'll skip this because this is just to scare everybody, like how the plugin framework looks inside. But there are supporting framework libraries that make this easier. I mean, all this boilerplate is just needed because there's a C backend that is needed to make stuff compatible on multiple targets. There's a lot of plugins included with full source code to get you started. So just take it and play with it and just try to change things. So a simple plugin is this correlation meter, which just shows you the correlation between left and right channels. And yeah, I'm not going to go into this, but as said, you can download the presentation. And this slide is basically just to show what is where and why it's there. So that's all the code for this metering plugin on the native side. That's all the code on the custom GUI side. So feel free to study that afterwards. These are some of the plugins that are included in this native plugin example library. Full source code. You get a convolution reverb here, and there's a granular synthesis effect. There are some equalizers, some metering effects. Let's take a look at some voice processing example where this could be useful. Say you have a game where you have two players communicating via let's say some walkie-talkie device, and you want to simulate that when they are very far away from each other, you want to make the reception really bad. What do? We take the source signal, we multiply it with some sine wave to make like this radio ring modulation thing. We add some noise, we add some EQ filtering, distortion, of course. It's just a chain of effects that we are applying. So let's try that. I will set up here. And voice effects. So this is what the mixer looks like. As I said, it's just a chain of effects. You see this whole chain over here, and this is what the voice sounds like unprocessed.
Hello, and again, welcome to the Aperture Science Computer
And now we
Data Enrichment
enable all the
Center.
effects. So make this controlled by distance, and you suddenly have a challenge hearing what the players, if you're very far away. That could be an interesting game element to use. Another thing we could look at is, because there's a lot of examples, there's also a granular synthesizer. That's not up on the link yet, but I'll probably be able to add it next week. So granular synthesis, just to quickly explain what it's about. It's about taking some sample and extracting small grains from it and playing them in random ways. So also not very typical for what game engines typically do. And I've used this with a sample of a hammer, actually. So you can see there are 4 hammering impacts here. And now when I play this, I can use it to make something that sounds a little bit like a car engine. So I can now increase the rate at which these hammer events are triggered. Yeah. It needs more work, but I guess you get the idea. Or like you could use this to turn simple raindrops into a waterfall like this. So here I just live edit the rate at which we emit drops with random speeds. And I can vary the speed. And you see the method is pretty light in the CPU, even though we are emitting like 50 samples. So it's just to show you that there's, with this system, that you can start doing stuff that just wouldn't be feasible to do with the plain audio sources because of all the overhead that is typically in normal audio. A final example, really quick, is there's also this thing called the teleport, which is it allocates a buffer of shared memory outside of Unity. And what we can use this for is we can actually take audio from other applications, such as Logic, which I have here in the background. So I have this track running in Logic, and let's play it. So now I mute this track, and but you can see I've placed an effect here with an audio unit effect, which is called the audio unit teleport here. And what it does, it takes data, routes it to the buffer, and now inside Unity, with this scene, so if I stop audio, it also stops in Unity, but we're basically routing audio from one application into Unity. And where this could be useful is if you're working on assets and you want to find out what like preview how will it sound inside Unity. You even heard that there's even a Doppler effect on it. So it's pretty useful, but it's just an example, and but the full source code is there. If anybody wants to work on this, please do. And I guess time is up, but I'll be sitting over in the big room like all day tomorrow, so I have way more demos to show you if you want to see more. Thank you.